I'm going to talk a little bit about Metro because I think their story was interesting as well. They historically used something called CCI from HP. Anybody ever heard of HP CCI? And nobody bought it, right? So HP released these blades. It was the E-class blades. Everybody's dealt with C-class, P-class before the C-class. Anyone? E-class was before the P-class. They were essentially little laptops. They were about yay big. You get about 20 of them in a 2U thing. I think it's 22, something like that, right? And they slotted in the front, and there was no, they each had a laptop hard drive on them. And then they went and said, here are your new servers, the world. And the world said, why on earth would I use this garbage? It's a desktop stacked up in my data center. Like, this is the dumbest idea ever. And so they sold 0 of them, and then they discovered that, hey, it is a desktop, and there might be a use case to actually run a desktop in my data center. And they sold up a bunch of them based on that. It actually worked. This customer was super happy with it. And but they had some lightweight use cases, and their CTO or CIO came to us and said, hey, we would like to run a bunch of Windows desktops under this new VMware stuff you've been running for us. He talked to the sales guy talked to me, and I said, you're batshit crazy. Like, why on earth would you do something like this, right? It's going to be expensive, it's going to be a mess. Brokers didn't exist, the term VDI didn't exist at this time. Right? This was early. But you know what? Hey, you're paying the bill. I'll go do whatever, man. Give me my bucket. I'll do that. So let's get it stood up. And it turned out it worked for a while until they ran their first virus scan. That was using HP XP storage, which is premier, top of the line, like VMUGs that fit in their big honking multi-million-dollar arrays. And I gotta say, the first time I've ever seen an HP XP meltdown was because of Windows XP. Didn't see that workload going to be the problem. So we had to learn all the stuff that anybody who's doing VDI today already knows natively. Don't run virus scan across 2,000 sessions on one storage array at the same time. Right? Like, this was a bad idea, right? There were a bunch of these sorts of lessons that we were just forced to find out on our own because we were blazing the trail on it. Well, eventually, they wrote their own broker, by the way, because brokers didn't exist either. So there's a lot of technology that just had to be built in order to make this thing happen, right? Today, they're on the 5th generation of this. It's been wildly successful. It is, like I said, now actually saving them money, and that's coming from independent confirmations. So that's good. And that's good for your normal 2D charting EMR application type use case. However, things have changed a little bit. So back when this started, office workers were just office workers. You ran office, right? If you were on Facebook, you did that on your own time. Everything was flat 2D, GDI primitives, normal, easy, RDP capable workload. Nothing big deal. And then their CIO, I love their CIO, he's a fun guy, and I'm not sure I love him as much as he does. And he likes publishing videos and getting his face in front of the customer, right? And so he was a fun guy to hang out with. So he's got a new idea, he's got something that he wants to bring forward, very dynamic dude. And they'll film a video with the marketing department, and then they'll send it out to everybody. And everybody clicks on it. And then your data set, you can almost see the smoke billowing out of the blades when 2,000 users click on a YouTube video at the same time. What we've discovered is all of your sizing, all of your architecture is relying on the fact that your average user at an average moment isn't doing much at anything. Right? Where they're logging in, they're clicking on stuff, but even as I'm doing this presentation, I'm interacting with the system for 100th of a second, about every 3 minutes, right? And we can average that out for a typical user use case, and we can see huge performance increases by throwing a lot of horsepower at a wide number of users because at any given moment, very few of them are doing anything. And that completely falls apart the second video comes into your environment, right? Someone clicks on go, it no longer is a GDI, Windows, primitives, dialog boxes, and text use case. It's now 720, 1080 times 1920, so a billion pixels, all changing 30 times a second, right? That's radically different workload from the sort of thing that you're normally dealing with in Excel or Avid or whatever it is that you're working with, right? So, I'd say a new kind of storm. We've always architected VDI environments around boot storms, around logging storms, around patch storms, and we've created tools and solutions that deal with each of these things individually. So whether it's late clones, whether it's the new stuff they're just talking about with Horizon 7, where they can deal with boot storms by spinning off all these machines from a running VM snapshot. That's cool technology. I haven't had a chance to play with that, but I like the idea. But it's this concept of a storm, of like something happening in the environment that doesn't just happen once, but happens across all of your desktops. And it wasn't a problem when you had 2,000 physical devices across your environment. It's more of a problem when those 2,000 physical desktops live on 10 actual things that are part of your data center, right? When something happens to all of them at the same time, big problem. And when it's video, really big problem. Right? Your utilization goes through the roof and everybody's having a crappy time whether they're watching video or not. It doesn't take too many of them before everybody is logging down. So that's a big issue. And we discovered in the computer marketplace a very long time ago that if you have any hope of doing video effectively, you cannot be doing it in software. It just doesn't work well. Was anybody around like in the mid-90s for the multimedia curve, CD-ROMs? The Microsoft Encarta, was that like the coolest thing going, right? So like that was probably around that time frame where this lesson was learned, right? We've known about it for a while. That's going back 20 years, right? And so then companies like Diamond Creative and then this new company, Video, that no one's ever heard of, started making these cards that were specific for these workloads. That they had hardware to deal with decompressing video, take that off of the CPU, and performance was just so much better. Right? It was a night and day difference. You're watching little Encarta videos, or you got big screen Encarta videos. Man, that was an exciting time. But this is not a new concept. In fact, it is such an old concept that pretty much everybody's forgotten about it. It just, you don't think about it anymore. You've got a video card in every single one of the devices you have. You got one in your, that's not my phone. You've got one in your phone, you got one in your tablet, you got, it's in your laptop, it's in your desktop. You can't buy a compute device that doesn't have this in there, except for VDI. So that's what you're doing. That's the one thing that people are still touching in an enterprise type environment that doesn't have a GPU behind it. And so that's really what's happening here. This is the problem around those video storms and everything else, is that you're trying to shoehorn a use case which we 20 years ago knew wouldn't work when it runs on a CPU. And we're still trying to do that today with Horizons and desktop environments, right? So I would propose maybe we could throw some GPU at this. 10 minutes? Okay, man, I gotta go faster. We could throw some GPU at this and solve these problems, right? So there's a bunch of ways that this can happen, and because I have 10 minutes left, I'm gonna fly through a few of them. In order of increasing performance, these are the solutions that are available on the market today. The very first one I'm just gonna call out as SVGA 3D is not 3D, right? So that's the VMware's software driver to enable 3D capability, but it's still running everything on the CPU. So it's something that I would probably recommend against. The only reason that I even call it out is because you're going to see it, and it says, you get a checkbox in the client that says enable 3D, right? You can just go ahead and check that. You don't need a GPU at all, so you check it, and now you got 3D, and you've accomplished nothing, right? So it's there. I'm not going to spend a lot of time on that. VSGA, confusingly named, not SVGA, but VSGA, is a driver intercept model whereby one GPU, I'm going to actually just show this by here. One GPU installed into the server has the capability to run multiple sessions, all sharing that physical GPU. And that has a VMware component that enables that capability. It's extremely limited. So DirectX 9, you can't do 10 or 11. It's OpenGL 2.1. If anybody's worked with OpenGL, that's an old version of OpenGL, right? Performance isn't great, it doesn't scale very well. Okay? But one GPU, no other special stuff required. And one of the big items with it is that it's vMotion compatible. It's that I can take a user that has this VSGA thing enabled, and I can move to another system like you would expect to in a vMotion environment, and it works, right? And the reason I point that out is because the rest of the stuff I'm about to show you doesn't, right? So, VDGA, vDirect Graphics. What we're doing with that, vDirect Graphics Association, is that I'm now going to buy multiple GPUs, put them in my server. If I put 4 GPUs in my server, I now can enable VDGA and get 4 users using that, right? That's it, that's the end of it. So that's a straight pass-through of that video card into the VDI section. And that works, and for some use cases, that actually is helpful, right? So some very heavy 3D users, that's actually a usable use case. I've got a number of customers that are doing that today. And it's kind of historically, it was the first actual 3D accelerator that could get me OpenGL4, that could get me DX11, that would get me a certified driver from NVIDIA or AMD that I could then load Autodesk on top of, or whatever other application suite. They would see that it's an NVIDIA driver, and it would thus be a certified solution, right? So that's a big deal. So it sounds a little ridiculous. As I'm sitting here before you, I can get now 4 users on one server. It's a hard cost model, and that makes sense, right? But there are some use cases where that does make sense, and we got a number of users that went down that path. But GM went long and deep on that for a long time. And it made a lot of sense for reasons I can talk about at extreme length, so I'm going to try to shut up a bit. vGPU. vGPU at this point now is kind of the Cadillac option, right? So this is something that NVIDIA developed alongside with to say, but now it has been fully enabled within the VMware environment. So as of vSphere 6, we have the ability to enable vGPU. vGPU gives me the ability to buy one of 4 different cards today. They can have up to 2 to 4 GPUs on it, right? Like we said before, I can put 4 GPUs, get 4 users. But with vGPU, I can essentially have a hypervisor for GPU. So now I can get 30 users on one of those 4 GPU cards. Right? And the RAM is statically allocated because frame buffer needs to be there at all time. But the compute end of it, if you're familiar with shader cores, that terminology makes sense to it, that can be time sliced and shared amongst users, whether they're using it or not. And so idle shaders can then be applied to another user. That ultimately is what vGPU is doing. Right? So I now have the ability to put a robust GPU hypervisor, I'll call it, into that platform. That's a ESXi 6 Enterprise Plus only option, right? Fortunately, when you buy Horizon, you get that. So that's a feature you can turn on. So hardware-wise, how do we do this? Well, you need the hardware to do it. Like I said, right now, today, it's pretty much an NVIDIA only game, right? That is going to change sometime soon, I'm sure. NVIDIA is now on their 2nd generation of this capability. It was what they originally had called Grid. They're still calling it Grid, but they're rolling 2 products into one at this point. So if you've run across Tesla before, the Tesla line and the Grid line are now Tesla with some Grid licensing on top of it, right? So if you get to the GPU compute world, that should be familiar. Anyway, K1, K2 cards are the 1st generation. They look like this. I will point out some things that might not be obvious, but here they are. It's double wide. It's full length. What you can't see on the end is that it takes PCIe power connectors. If you run, anybody play video games at home? PC gamers, anybody? Master Race represent, all right. All right. And so you've dealt with those PCIe connectors, right? And it's just something that you only do if you're doing, video cards into desktop PCs. And when I say that, what I mean is if you open a server, you will not find those connectors, right? Moreover, anybody notice anything missing from this card that you would normally see on a big, hot power? And no fans, that's right? There's not a fan on there. And so we need a number of things from the server that this is going to plug into. It has to be a grid certified server. Short version of that, you need passive or cooling that's going to blow enough air through that in the server already. You're going to need those power cables, and probably you're going to want riser cards that are going to deliver 16 PCIe 3 lanes to these cards, right? I'll use as an example, if you're buying an HP DL380 Gen 9, They sell what's called the DL380 Gen 9 GPU enablement kit, which comes with those things, right? You get a new riser card, it gets rid of the 8-way lanes and turns it just into 2 side-by-side 16-way PCIe slots, and you get the power cables that will plug this thing in, and now you can get 2 of those and 2 of 3. Okay? So if you're going to spec these things out, understand that you're going to need potentially a special server, or you might be able to retrofit the ones you've got in order to enable this. They're big, they're heavy, they need cooling. Okay? You can slice and dice these things different ways. There are some limitations as to how you can do it. Like I said, there was it's like a hypervisor, but you do have limitations as to how you do that slice and dice. There is one major factor that's going to impact you, and that's the GPU RAM that's on board. So 2 models, you've got a K1, you've got a K2. K1 has 16 gigs of RAM, the K2 has 8 gigs of RAM. The K1 has 4 GPUs, where the K2 only has 2 GPUs. But the K2 is the bigger card. Those GPUs are much larger. And so here, I don't think actually I've got it. There's 3,800 cores across those 2 GPUs. Here, I've got 1,400 across the 4. This would be your scale-out solution. That would be more appropriate for healthcare. That's the video, the 2D users, and I can get 32 users on one of these cards, right? This is the scale-up solution. This would be going to be your advanced 3D, your architectural, your manufacturing, that sort of thing. I get fewer users per card, but way more capability and performance. That's where you're going to go for the 3D interface. You have limitations from the frame buffer, which is just going to be a picture in memory of what's on the screen right now. This lives in the frame buffer of this thing, right? And what that means is that it's going to scale based on how big this is, not physically, because that doesn't work. This is really big. But your resolution, whether you're doing 1920, how many of those monitors and what your color depth is, right? So you just multiply out the number of pixels and multiply it out by the color depth, and that's just how much RAM that's going to take. Full stop, you gotta have it, right? Yeah. And so I want to throw out here, there's also a new version where we have only one card that you're really dealing with, but then we also have a blade version. So that's a new feature, right? We can put these into an HPC class blade or a Cisco UCS, has it as an option. No more scale out or scale up. This thing is both wide and deep, right? It's 16 gig of RAM. It's got all the horsepower you want. It's now Maxwell generation, which is like the 900 series GTX. If you got a GTX 980, this is basically the server version of that. It is also what you're going to require for 4K. So you cannot do 4K on the K1, K2s. You got to do one of these. Just to show I'm not lying, this is a typical DICOM viewer. It's an application known as Slicer. The stuff works, it's fast, it's a little creepy, but there it is, right? It's fast, it's performant. This whole session has been run from a data center in Grand Rapids, Michigan, right? So I'm using Verizon to attach into it. This stuff is snappy. There's 100 milliseconds or so latency between us and them. It feels local. I have Steam loaded up in here. I didn't bring my Xbox controller, but I can play video games from here, right? We can run engineering apps from here. We can stream 1080 video and stuff works. So. And I think I'm out of time here, so I'm going to go ahead and let you guys go. If you want to talk to me, what do we got for the room? Is there another group coming in here? Do we have any group coming in? Okay, so I'll go ahead and hang out in the middle area here if you guys want to yap about what the solutions are. We've touched a whole lot of customers. We've seen a lot of success with this. It's not for everybody. You have to cost justify it, but for those use cases where it is cost justified, there ain't nothing like it on the market. And VMUG's got some killer stuff here. Thanks, everybody, and enjoy the rest of the show.
Thanks, everyone.